All right, you guys, interval notation. A couple of you told me I didn't really go over this last year. I believe you. I think I maybe said it once or twice. I don't know about Mr. Ryder, but interval notation is just like if we have a number line. I'm sorry, it's a wavy number line. Let me see. Let me see if I can make it straighter. If we have a number line, you guys are just gonna have to deal with it. Let's look at A. Okay, all real numbers greater than 3 and less than or equal to 12. So here's 3 and here's 12. If you were going to draw this on the number line, you would say, okay, greater than 3 but not equal to 3. So that's going to be that open circle. Greater than or equal to 12, that's going to be that closed circle. And you would draw the line in between those two, and that represents all of those numbers. Interval notation means we would write it like this. We would say it is greater than but not equal to 3, and that means like a circular parenthesis. That's not the right term. I think it's just parenthesis. Okay, so you put 3, right? And then comma, and it goes up to 12. But you guys, because it can be equal to 12, instead of the regular parenthesis, we put a square parenthesis, right? So kind of the curved parenthesis is that open circle, and the square parenthesis is that closed circle, okay? So B, all real numbers greater than 0, okay? And it says greater than 0, it does not say equal to 0, so we have curved, we have 0, and then what does it go up to? Who knows? It never stops, right? And we call that, you guys know this, infinity, right? And then you're saying, well, is it equal to infinity? Like, what do you do? If you have infinity, it's always going to be curved. That's kind of that ambiguous, like, we don't even know what infinity is, right? We're going to go ahead and use a curved. All real numbers less than or equal to 0. So this is interesting, you guys, and I'm going to draw it out over here because in this case, we have 0 here, right? And that's going to be a closed circle because it can be equal to that. But otherwise, it's going to go this way to negative infinity. And we have to write the smallest number first. And the smallest number here is negative infinity. Okay, and our largest number is 0, and that's going to be square bracket. Okay. D, all real numbers less than or equal to 5 and greater than or equal to negative 5. So that's going to be the numbers in between 5, negative 5, and both closed circles, so both square brackets, right? Here we go. And you always put the smallest number first, so negative 5, comma, 5, there. All right, all real numbers less than 2 and greater than 3. It says careful. Why? Why? Because when we look at a number line and we have 2 and we have 3, it says less than 2, which is this way, and greater than 3, which is this way. So we're actually going to have 2 sets of parentheses. One set of parentheses is going to be negative infinity to 2, right? And both not going to be equal to 2, so I'm going to do that curved parenthesis. And then you guys, this is a symbol you're going to learn, and the way I remember it is because it kind of, the and symbol kind of looks like an A, right? And then you do your other set of parentheses, and 3 to positive infinity, okay? So because there was nothing in between those, and then don't forget this and actually has a symbol there. All real numbers less than 2 or greater than 3. Okay, so do you see what they did? I had to read that slowly to see the difference. They used an or instead of an and. So instead of the like A for and, we do this. It's going to be exactly the same, comma 2, and then you're going to have this 3, comma positive infinity. Okay, but instead of this or is a different symbol than and. This or is like a U. Or Okay, so they're not really an A, they're not really a U. I remember that the and kind of looks like an A, so the or must look like the other one. They kind of look like parabolas, actually, if you think about it. So again, this is one of those things. Hey, maybe in your notes, write a little section that says interval notation. Actually, in fact, I'm going to say this right now. Let's see who's watching these videos. Bonus points if you can show me first thing Monday when you come into class while I'm checking homework that you have taken notes on interval notation and simplifying radicals and anything else that you did here. Not just doing the problems, but just kind of taking notes on how to do it, okay? All right, simplify. So this is getting into factoring. And remember, fractions just mean dividing, but you can't really, this was like one of the last things we did last year. You can't cross anything out if you have more than one term, okay? And that must be a plus. And I don't know if this is a plus or minus. I actually think this is a minus, you guys. I'm sorry. Actually, maybe I can check the actual review packet. Review packet. Nope, nope, yes. Question number 18. It must have uploaded funny to my deal. I guess I could have paused this, you guys, but, oh, minus 7x plus 12. Okay, good, I was right. So we're going to go ahead and factor. The top is just a binomial, the bottom's a trinomial. We have to factor those first. So if you remember, and I went over this in class, on the top one, they each have an x. We didn't really go over last year trinomials that had a greater than 2 degree, like this 3, except in this same case where we can take out an x. Watch, if I factor out an x here, right? And then I just have x squared minus 9 left over. Why? How does that work? Because if I distributed, x times x squared would be x cubed, and x times negative 9 would be negative 9x, and that's what I started with. So I factored correctly, okay? But then, look at this. This is a rule. I know if I have a perfect square, and x squared is a perfect square because x times x is x squared, and another perfect square, and I know 9 is a perfect square because 3 times 3 is 9, and I'm subtracting them, there is a rule, and this might be good to write down factoring trinomials in your notes. There is a rule that says this is how I do it. I simply say x times, and then I'm going to put 2 parentheses here. This x is this x from here. It doesn't actually have anything to do with the rule, I'm going to say. I take the square root of this first term, x squared, okay? And I'm just separating these out. And then I take the square root of that second term, and then I add once, and I subtract once. And that's the rule. If you don't want to memorize a rule, that's cool. You just do this. X squared minus 0x, because there's no x there, right? Minus 9. And when we're factoring a trinomial where the a is just 1, we just think of this. I need 2 numbers that multiply together to give me negative 9. And add up to give me 0. That, I guess, could be a plus. It doesn't matter. 0 is neither plus nor minus. And those numbers are negative 3 and positive 3. Negative 3 times positive 3 is negative 9. 3 minus 3 is 0. And that's where this plus 3 and minus 3 come from. That is why that rule that if you have it memorized works. Okay? So the top, the numerator is completely factored. Let's do the denominator. Okay, we have x squared minus 7x. Let me put this farther down and then I'll erase it. X squared minus 7x plus 12. Because a is just 1, right? I'm looking for, oops, that's a minus. I am looking for 2 numbers that are going to multiply together to give me positive 12 and add up together to give me negative 7. I will talk for just a minute to figure out if you guys can come up with that answer first. And it is negative 4 and negative 3, because a negative times a negative is a positive. It gives us our positive 12. But when we add them up together, we're going to get a negative. Okay? So the denominator is going to be completely factored form x minus 4 and x minus 3. Okay. Now, the reason we need to factor these is because now we can actually figure out what we can cancel out. And right here, because you can only cancel things out that are being multiplied. And now I have things that are terms, whole terms that are being multiplied. Even though there's more than one item in those terms, you can still cancel them out. X minus 3 is the exact same thing as x minus 3 here. Okay, so the most simplified form here is going to be the numerator is x times x plus 3, and the denominator is x minus 4. And remember, we talked about these last year when we were trying to find holes in equations, when we were doing rational functions, right, with denominators. And here at on the denominator, x cannot be equal to positive 4 because that would make the denominator 0. But also, before we cancel this out, x could not be equal to positive 3 because that would also make the denominator 0, right? So just to try to jog your memory about when we did this last year. Okay, so B, let's see, B, A is just 1. So I bet I can do this in my head. I'm looking for two numbers that multiply together to be -8, add up to be -2, and that's going to be -4 and +2, right? Does that work? -4 times +2 is -8. -4 plus +2 is -2. So my numerator is going to be x minus 4 times x plus 2. And my denominator is going to be 2 steps because I have a degree 3 here, and every term has an x. So if I, first of all, just take one of those x's out, it'll give me a quadratic, and then I have x squared plus x minus 2 left over. And I'm pretty sure I can do that in my head. Two numbers that add up to be +1 multiply together to be -2. It's going to be -1 and -1. But don't forget, I need to keep this x that I originally took out. So we have x times x minus 1 times x. Nope. Look, you guys are letting me get away with doing that wrong. Two numbers that multiply together to be -2 and add up to be +1. And that is going to be -1 and +2. So x minus 1 and x plus 2. The reason I caught that mistake, you guys, was because I was pretty sure these questions were going to want to be able to cancel something out. So I either had to have a +2 or a -4, and when I didn't, I knew that I had done something wrong. So now that these are both +2, I can cancel those out. So the most simplified version here is going to be x minus 4 over x times x minus 1. And the holes in the equation would be at -2, +1, and 0. I'm going to stop this video here because I'm already at 13.5 minutes, and start again at 18C.